YouTube, welcome back to WFT Rc Cars. So, one question that's popped up on the channel from Razor RC, and nice to see you watching channel, mate. I've been a subscriber on for quite a while. So, question that's come up about powering the new R7P receiver using the G7P as your transmitter for a nitro car. And I realise it's something that I've not really covered that much before. So we've got a typical setup here. So rather than an ESC, you've got your battery pack, you've got your steering servo and a throttle servo. Bit of a difference between them two on speed, but I'm just going to run you through a general setup. And again, I'm going to do this outside the RC because it's a lot easier to see what we're doing with rat's nest of wires, and show you guys how I would set it up just typically for your standard nitro car, where you've got a receiver pack, a receiver and two servos. I'll run you through setting the failsafe as well, because you don't want a nitro car running off. The electric cars, they generally, if you lose signal, will just sit there and stop. A nitro car or an IC engine car, petrol engine, gas car, they're going to behave different. So you want to make sure you've got your failsafe set. I would set the failsafe on any RC, but once you've got an internal combustion engine in there, you could end up in a mess if you don't get this set up right. So let's get you in for a closer look, and I'll run you through how I plug everything in, and then how we do the settings on the G7P. Right, so basically we've got a controller on. We're going to go into model memory. You're going to select a blank model. Once you've done that, you're going to want to give it a name. So delete everything that's in, and we're going to call this one R7P. So once we've got that done, we can then back out. Now we want to go to bind our receiver. Now this can be powered from any of the ports. So we can power it from anything at all, as long as you've got the negative to the rear pins. So that's these bottom ones, or any of these side. What I would do is basically your first 5 are channels. So you've got channels 1 to 5 running through here. You've then got a bind port, which is not needed on this receiver, and you've got a voltage monitor port, which you may decide to use. Not really necessary on a nitro, and I'll show you why. You've got channel 6 and 7. This top port is for your S.BUS connection, and this bottom port is for your external sensors. So what I'm going to do is power it through the bind port. So that's the second one down. That leaves all as channels, sensor ports, S.BUS and voltage monitor free. And you've got this tiny little bind button here. So I'm going to put it into bind. I'm going to choose two-way because it's a telemetry receiver. So it'll work in two-way. RX type we're going to leave as standard because it's not one with an ESC. We're going to leave the PWM S.BUS settings alone. I'm going to come down to servo. I'm going to change this one to other. And then I'm going to go in and I'm going to change this to 333 Hertz. I'll tell you why now. So basically, most servos, unless they are really old cheap ones, will be able to cope with 333 Hertz. Now we're running a Spectrum and a Traxxas servo, and these can run 333 no problem. The only time you may get an issue with this is if you've got an old analog analog servo, because they only run at 60 Hertz, most of them. Now if you get a more expensive servo, you can run up to with this controller, it'll go up to 400 Hertz. The instructions of any reputable servo will tell you the operating frequency of the servo. Now, if you've got the MB4 or Pro, You can run up to 1000 Hz on those, which I've got one of the Theta servos, one of the Fastech. I've got one of them that runs at 1000 Hz on the Pro and MB4, and it works fantastic. But what will happen if you get this wrong? So, if this is too high for the servo, when you turn your steering or your throttle, rather than a nice smooth movement, this will start to turn, but then you'll see it kind of turning erratic, or it might move so far and then drop back a little bit and then go forward again. So if you've got this set too high on a cheaper servo or a lower quality servo, you'll end up with, rather than your steering feeling nice and linear, you'll end up with like mushy feeling, or this servo arm will kind of twitch, or it'll stay at center, but as it turns on your steering, it'll get vague in the center and then kind of pick up again. So you really need to know how to set this polling rate. On all the Flysky receivers, it's called frequency, which is what it actually is. But on some transmitters, some brands, they'll call it polling rate, which is also correct, because it's just the amount of times a second your transmitter is telling your servo where to be. It's just important that your servo can keep up with the amount that you're telling it. The reason I say 333 is because most Savox servos and most branded servos can happily run at 333. The only time you may get a problem with this, and I've encountered this, is I have some Traxxas ESCs that can't cope with anything above around 280. So the easy way to tell that you've got this right or wrong is read your instruction for your servo or your ESC. Another dead giveaway is when the servo's sat at center, it'll start twitching. And also, as you try and move it through its movement, you won't get a linear feel all the way through. As I say, it might start and then go a bit mushy and twitchy in center and then go okay when it gets to top. But it is important to understand what polling rate is. And it is nice that even on a £60 transmitter, which is roughly what this is, they have left the option in to be able to correctly set it up for any type of servo. So, moving on, what we're going to need to do now is bind. So I'm going to start the receiver, looking to bind. I'm going to press the bind button and I'm going to connect as power. So you'll notice as receiver flashes quickly, then it stops. So if we come out, we've got RX voltage, 7.6 volt, because these can run from 3.5 to 9 volt. And I'm running it off a high voltage LiPo. So it's a HV LiPo, this one. So we get in 4.9 volt on the transmitter itself. We get in 7.6 volt from the LiPo. Now, if you were running this on an ESC, you'd get whatever voltage your BEC is sending to the receiver. But you might want to monitor your external battery. So at this point, you'd plug in your external voltage monitor, you'd get the positive plug, and you'd plug it into the positive on the bind plug. And then if we press down, we can see as battery voltage detection, 7.7 volt. Now, you will always get a very slight different reading from the actual pins that are on the whole battery packs compared to the one that's coming off the balance lead. It's usually very close, which on this, it's 0.1 of a volt. So, to all intents and purposes, close enough. But, let's get that unplugged, so it makes it a little less confusing. So we're going to plug our Spectrum servo into a steering on channel 1. We're going to get us Traxxas servo and we're going to plug that into channel 2. So let's see if I can get these in shot for you so you can see what's happening with them. So if we look, we've got us throttle, forward and back. and we've got a steering. Now, because we've got it set at 333, we've got no weird twitching at all, and if you notice, there is no sound coming from this servo until you start to move it. If you've got your servo with no load, so you've not got it connected up to anything, and you're getting sort of that sort of effect, so you can see it just twitching, it's not holding center, it's a dead giveaway you've got your polling rate set too high for that servo. You'll also notice you'll get heat build up in it. And if I pull the throttle in, you notice how we've got nice, steady, linear response across the whole sweep. And that's because the polling rate is correct for this servo. Bit harder to see on the Spectrum one, but you'll notice as soon as I start to move it, it moves, and it continues to move the same amount through the entire sweep. So what else do we need to do if we're setting it up for a nitro? One of the most important things I would say is your failsafe. But before we go setting failsafe and everything, so we'll notice with the splines on this servo horn, it's not exactly central. Now that may be how you need it in the car, but first thing we can do is go in. So we're going to want to set as sub trim, and I always find it better to do this before you get setting your endpoints and everything. So it allows you to correct for the splines on the servo horn, so then you can get your servo set up nice and central. Then you want to go in and set your endpoints. So we're going to come down to throttle, so as throttle back and as throttle forward, because you may not need it travelling all that far. So if I pop that down so we can put on the brake, and then as you bring this number down, you're going to reduce the travel, because you may only need a slight bit to brake, or you can take it up to 120 because you might need further. Now, not all servos will be able to move over the full amount of travel if you set it to 130. And again, you can do it for your forward travel. So if it's trying to push on your carb too much, you can go on and you can back it down, so you're not straining the servo against your carb. Now, just because it makes it easier to see the amount of movement, I'm going to leave them on full. You can do the same for your steering, so you can bring your endpoints down so your servo isn't trying to strain at full extent. Servo reverse, self-explanatory. Channel 1 is your steering, 2 is your throttle. If it's moving the wrong way, just click on it and then reverse it, and then you can click off it. Right, the next really important thing is failsafe. So on an electric car, generally when you turn the power off, you lose from the controller. Most ESCs will just go, right, I'm getting no signal, and they'll stop. Not all, but most. On a nitro car, if your batteries go flat in your transmitter or you've got a problem with your signal, the last thing you want to do, if that's as throttle, is that to happen when the controller turns off. Now, if you don't set the failsafe and you turn the transmitter off, when you first turn it on, it'll tell you you've got no failsafe set. So you can press yes on there and get to it. You can also go through and you go to your RX menu and then failsafe. So that positions as throttle, that's as brake. Generally, we don't care what the steering's going to do, because if the car's not moving, it's not moving. So let's try setting set that to 50, back out, and then see what we get. So now it puts us brake on. So that percentage is also affected by your trim, your endpoint settings. So you're going to have to play about with that. But if we set that so the brake comes on slightly, the one thing we're not going to do is get a nitro car travelling at 40 odd mile an hour and just shooting off because we've dropped his controller and batteries have come out. So again, if we wanted to add even more brake, we can come into it. Let's try going right way. So set it to 90. Then if we lose power, we get a lot of brake. You don't want it forcing too much, so you'll have to play around with percentages. Set all your endpoints and everything first, and then set the failsafe without the engine running. You just want to know that if all else fails and you lose connection, you're going to have brake and nothing else. You just don't want it turning off and going, way, here's 40, 50, 60, 100% throttle, and then you're chasing a nitro and trying to catch it, and you're going to burn your arms, break your nitro car, run people over. It's not good. For the few seconds it takes to set that fail-safe, if anything happens then, your car brakes and it stops. You can do the same. You can set a fail-safe for steering as well. So if you wanted to go in, and you can set your fail-safe, and you can set your steering, and you could put your steering on 100% one way or other. So all your car's going to do is sort of brake and turn. It's not going to go anywhere, but I usually find it better to just leave steering where it is and just set the throttle, mess around with the throttle and brake setting so it applies brake when it stops. If you need to set any of the other channels up, we go into the auxiliary menu, you pick a channel, you then pick whether you want a trim function, a switch function, or a knob function. So if we decide we want it on a switch, so we can come out and that'll set channel 3 to a switch. And if you press up on your controller, you can see what position everything's in. You can see what your throttle and brake's doing. And then if you press down on the controller, you get your BVD voltage if it's connected. Basically all your values. You get your signal reading and noise reading. So, hopefully that just about covers it. So, let's wrap this one up. Right, so we have fully functioning throttle. We have as failsafe. Hopefully that's cleared up why you may get some issues with older or cheaper or analog servos. Also goes a long way to explain how you can get issues where you feel the servo's not doing what you're telling it to do with steering and throttle. You can get the same issue if the polling rate is incorrect for an ESC as well. One of the dead giveaways is you can be in a situation where you plug it in, the ESC will technically go forward and brake, but if you try and calibrate it, it won't end the calibration process. And that's literally because the polling rate is too fast and it's not really sure where your controller's telling the ESC to be at. So you might think you're asking for 20% or 50% on throttle, and it's getting a varying sort of, it's not sure what it's being told what position to go to. Most reputable servos will run at 333 and so will ESCs. As I say, I have got some Traxxas ESCs that will only go to about 280. But hopefully that clears it up for you guys and helps a few of you out. I know if Razor RC is asking questions, I know a whole load more of you is going to be thinking exactly the same. And it's nice that we can all work together as a community to sort of learn, spread knowledge, spread the enjoyment. But Thanks again for watching WTF Rc Cars. If you like this kind of content or find it useful or helpful, please share to friends and family. Don't forget to hit the notification bell, and catch you guys in the next one.